Welcome back to Easily Explained, where today we will be learning how to solve inequalities. So let's get started. Solving an inequality is very similar to solving an equation. So let's just ignore the inequality sign first and solve it how we would normally solve it. If there was an equal sign right there. First we would get rid of the 15. So it would be 3x is equal to 15, divide either side by 3, and we would get x is equal to 5. So in the same way, we're still solving the inequality with the exact same properties. Division property of equality. However, instead of having an equal sign at the end, we'll have a greater or less than sign. So the solution to this inequality is x is greater than 5. But there is one thing that is a little bit different. Take this inequality, for example. 3 minus 4x is less than or equal to 11. Alright, let's solve. Negative 4x less than or equal to 8. Now, whenever we end up with a negative coefficient here, we're going to divide it by negative 4, correct? However, when you divide or multiply an inequality by a negative value, the inequality will flip. So, you'll actually get x is greater than or equal to negative 2. Alright, let's test this out. Let's just give a random value to x. 2. 3 minus 4 times 2, so 8. So over here you get negative 5. That's correct, right? But here we were given that x is greater than or equal to negative 2. So let's give x the value of something less than negative 2. Let's give it a negative 3. 3 plus 12 less than or equal to 11. 15. That's not true. 15 is not less than or equal to 11. So that's why we had to switch the sign. Because when you multiply or divide by a negative, then the sign has to flip, because otherwise the statement will not stand true. Alright, now let's learn how to graph the solutions of an inequality. The first thing you want to draw is a line, a graph. Alright, now you want to add values. Here we know that x has to be greater than or equal to negative 2. So let's just make a bunch of little values. Let's start from negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Alright, so our solution is x is greater than or equal to negative 2. So let's first find negative 2. Here it is. When there's also an equal to sign, we want to make it clear that x can also be negative 2. So that's why we fill it with so that's why our dot on top of negative 2 is filled. If we were given x is greater than negative 2, and this was negative 2, we would put a unfilled dot. Alright, let's keep going. Alright, now we know that x can be any values equal to negative 2 or greater than negative 2. So now we want to show, since it's greater than, that it can be any value on this side. Alright, let's do some practice. We just have 2 practice problems this time. I want you to solve number 1 and number 2 and graph them both. Okay, let's go over it together. Plus 3 on either side and plus 4x on either side. So on this side we have negative 2x, and on this side we have 4. Let's divide by a negative 2, and remember now that we have a negative, we divided by a negative 2, that means we have to switch the sign, and we have x is greater than or equal to a negative 2. All right, let's graph. Oops. All right, greater than or equal to your graph. So your graph should look something like that. All right, next problem. Let's use the distributive property. 3x plus 21 is greater than or equal to 4x plus 2 times 8, 16. All right, let's get rid of the 16 on either side. Let's get rid of the 3x on either side. So we just have 21 minus 16, which would be 5, is greater than or equal to x. So basically x is less than or equal to 5. All right, let's graph. X can be 5 or less than 5. Your graph should be something like that.
Congratulations! You are now an expert in solving inequalities. We hope this video really helped, and we'll see you guys next time. Bye!